So earlier this year, I undertook an experiment to try and recreate the InVision App user interface using Angular 5 and the new Angular router. And it worked, pretty well. I'm actually really excited with what I had come up with. There are no images, but essentially you can click through the application. And, I did my best to recreate the sort of gesture of the overall Angular application, of the overall InVision application, right? Inbox and things like product updates and so on and so forth. Anyway, so now that I've recently been experimenting with ahead of time compiling and lazy loading of feature modules, what I wanted to do was revisit this InVision app experiment and revamp it to use ahead of time compiling and lazy loaded feature modules. And I was able to get this to work, and I just wanted to share what I've done. So if we just go back into the root of the application, and let me just refresh the page, and we look at the network activity, what we can see here is that we have our main bundle, we have our vendors bundle, and our runtime bundle, right? And these are the three bundles that I needed to load the application. Now, this bundle takes care of things like the projects list, and when I go into the main project detail, you can see that we don't have any additional bundles. And actually, let me just filter this on JS. But if I do something like go into the console, you'll see that we just loaded this new bundle. And if I do something like go into the inbox, you'll see that again I loaded another bundle here. And these are lazy loaded feature modules that Angular is pulling into the application as needed and merging into the active configuration and the active routes. And nothing super groundbreaking here. This is a lot of stuff that I've actually covered in previous posts, but I was just excited about how easy it was to actually integrate lazy loading into the Angular application. Now, the patterns that I've developed for doing this makes it so that the parent modules never really need to know about the lazy loading. So for example, here's my shell view, and the shell is kind of the main wrapper for the application. The shell view here has a bunch of children: boards, console, freehand, inbox, modals, oops, product updates, and standard, right? And you can see that when I import, I'm importing the modules from all of those child views, and then I'm importing the routes from all of those children. Now, some of these modules are statically loaded with the initial bundles, and some of these modules are lazy loaded as on-demand features. But what you'll notice is that there's nothing in this code that indicates a difference between the two approaches, right? So for example, the modal view, those are all statically loaded in the initial bundle, but the product updates is a lazy loaded feature module. But you can see zero difference between the way that these two different things are imported and exported. And that's because the exported routes and the exported modules completely encapsulate the type of loading that pertains to that feature. So for example, if we jump into something like, let's go into the oops view because it's small. Right, here's the oops view. The oops view, which is an error view, is statically loaded with the initial bundle. So you can see that the modules that I'm exporting contain the oops view module. And then the routes that I'm exporting are the non-lazy loaded routes. These are just being pulled into the parent route configuration at compile time. Now, if we contrast that with something like the product updates, we can see in this case the modules collection that it exports is empty, and that's because the routes configuration that exports isn't a static route configuration, it's a lazy loading configuration. So you can see when I go to the path product updates in the secondary outlet, I'm going to load my product updates module, and then here in my module configuration for product updates, here's where I'm using the router module for child. You can see here's where I have the lazy loaded route configuration. So by exporting both the modules and the routes from each feature module, what it allows me to do is seamlessly change the statically loading versus lazy loading without having the parent know about the differences. Again, because they both export modules and routes, so we can see here with the lazy load, the module is empty. When I go back to the oops view, right, the modules contains the module that the parent is going to need to import at compile time in order to get all of this to work. So I've just been very pleased with this pattern. Again, it keeps something like the parent completely oblivious to the fact that something is lazy loaded or statically loaded, and it makes it really easy to change the approach internally to a feature module. Now, I know, again, you could argue that it shouldn't be the feature module's decision as to whether or not it's lazy loaded, but I just don't feel very strongly about that. I'd rather have nice encapsulation in the feature module than have a feature module that I could theoretically share across applications, which in my experience with Angular for the past like 5 or 6 years has basically never happened. So it's just not a problem that I need to solve for. Rather, I'd like to solve for better encapsulation and more consistency in the semantics, and I think that's what I've done here. But regardless, this isn't really an argument about how to do lazy loading. Mostly it was just the fact that I was able to revamp my InVision experiment here to use lazy loading against initial bundles, and then only additional features get loaded as needed as I navigate through the application. So anyway, take a look. I'm pretty excited about it. I'm pretty excited about how easy it was to integrate lazy loading. And again, just reminds me how awesome Angular is as web application framework.